So let's create an RPM now on the CentOS machine. So let's connect to this CentOS virtual machine. Okay. You need several directories to create RPMs. RPM build with several directories behind. In /vagrant, I've already provided this RPM build directory. So let's copy it with recursive vagrant RPM build. Okay, so in RPM build I have a build, RPMS, sources, specs, and srpms directory. I also need a small macro, RPM macros. Top there. /RPM build, just to specify where the RPM build package is present. Okay, now everything is set up to build a package. To build an RPM, after that you will need a spec file, which is a description on how to build a package, and the source code, of course. So for the source code, I go in RPM build sources. Let's clone the source code. Okay, I'm cloning the same materials and for Ubuntu. Okay, and I create an archive for this. Training.0, the version .gz. Okay, now I have an archive where all my source code is available. So sources is where you place your upstream code source. The specs will be where we specify how to build a package. So we have none for the moment. You have in the PDF materials how to create this spec file, step by step, description of all the different categories, etc. But for the sake of this training, to speed up the training, I have created a training spec file. So training, the name of your package .spec. So, okay, so let's have a quick look at the file. So I have specified that my package is named training, its version. This is important. The source is where you can get usually your file. In fact, it should be a new URL. You don't really care, in fact, it exists or not. What is very important is the trailing name of the URL. The name of a package dash your version. We can use variable names .r.gz. This should match the name of your archive in the sources directory. My description, I specify I want a Devel package, and I want a binary package. For this training, I just create in the binary package I will put the binary and the shell library, and in Devel I will just include the shell library with header files for development. I could have created another lib package just to put the shell libraries, but here I will put everything together. The prep will extract the archive, training version in fact. We execute for the build a configure and a make. Here, of course, if it is a Java, you could use your own build file or anything. You could specify your own flags. In fact, you describe how to build your software. The install section is very important because you have to specify, just like for Debian, where you put the files, the generated files, in which package. So create a RPM build root. It's where the package will be present. There's nothing more here. I just execute the install command. So I say install the package with the prefix make command, in fact, in RPM build root. Post and uninstall. As for the binary package, for example, I want to execute a ldconfig, so it's really at execution installation time. I want to apply one or more commands. So here, for example, I want to declare my new shell library, which is present in the binary package. As you can see, package devel, package bin. I don't specify the whole package name, I just specify the trailing name, so it will be training-bin, training-devel. And files, I specify all the files present in all packages. In my bin package, I want to have the bin dir, user bin. It's a predefined macro, but you could specify the full path. I want the squeeze executable. I want to put some documentation. And I want all the .aso files coming from the macro libdir in USR lib, for example. You should use the macros because it will adapt automatically to different architectures, USR lib or USR lib 64, for example. In devel, I want to include all under USR include squeeze and the .so symlink. All the generated files should be present here. If you have some generated files not present in one or the other binary package, then in the install step, for example, you should delete them from the RPM build root. And the changelog, mandatory too, where you specify for each version, etc., what you have done on the package, who, and at which date. Okay, so let's try a build to generate the RPM. Oops. So an RPM build command that will be build a binary package of my spec file, training spec. So it uncompresses the file, the archive file of the source. I execute the configure and make command I specify in the spec file. So for the moment it's a compilation. And at the end of the build it will apply the install loop. Okay, so as you can see, I have an error. I have executed chrpass command, which is not yet installed on the system. So as an error, it is stopped. Install. Is it the package name? Oops, I need a sudo. Okay. This is only for link time, we don't really care for this packaging. Okay, I'll try again. Each build will be created in a fresh root directory. So it will uncompress and reconfigure, etc. on a new directory for all builds. Okay, now we have seen many things. You have some RPM macro, for example, checking for Python, checking for Java, many scripts, many apps. Okay, where is my package? Okay, so here we can see the generated packages. A source RPM, so the source code, and the binary packages in RPMs for my current architecture. Of course, I've built it on CentOS on 64 bytes architecture, so it's present here. content now. So let's go into RPM. And this RPM is the one you will install or distribute. RPM QRP of, let's have a look at the binary package, for example. Okay, you can see now we have the binary and my shell libraries. So my package is available. Yeah, just like lint and Debian, you have RPM lint you can use to check your package. So for example, here you can see that it does not find this URL. Well, that's fine. You have shell libraries, links, or warnings, one-line command, whatever it's. So if you have some errors, you find something which does not find your package, RPM lint will give you hints on how to fix your package. So now I can try to install it to check that everything is fine. Do not forget to always test the installation of your package. And I need to sudo. Okay, and now let's check squares. Okay, it's present. And you can see that my binary is linked again against my install libraries, for example. So I have built a package. Now you can have a look at the PDF material to go through a step-by-step spec file creation and analyze what are the different sections and what is needed to build it from a fresh new spec file.